Okay, we are making the assumption for this answer that this is supposed to be a y right here. That's with some high probability likely to be the case. And the first thing to notice is that even with this sketch of the graph here, if you weren't using a graphing calculator like Desmos, you'd have to find the points of intersection would be the first step. So you'd have to say, well, x squared equals 6 minus x and solve that equation to find the x coordinates of the points of intersection and then find the y coordinates. Okay, I'll leave that to you. If we're going to integrate with respect to x for part A, we want our typical little rectangles to be vertical. And we like to come up with an expression that represents the length of this rectangle. You probably did this with Riemann sums. And so the length of that rectangle is what we say is it's the y coordinate at the top minus the y coordinate at the bottom. That's how you find the distance between points on a horizontal or on a vertical segment. So that's what this is right here. There's the 6 minus x. That's the y coordinate at the top minus the y coordinate at the bottom. The reason that works is because if I picture extending this all the way to the x-axis, this distance right here is 6 minus whatever x coordinate we're dealing with. And then this distance is x squared, or x sub I squared. And so top minus bottom will give us the length of the green segment. So there's the integral. We're going from -3 to 2 along, because these vertical rectangles are piling up perpendicular to the x-axis. So we're integrating from -3 to 2. And you can see the answer there. I'll assume you know how to evaluate this definite integral by finding the antiderivative, and you get 125/6. Now this mess comes from integrating with respect to y. Let's go to the next board and see what's happening. The key is that if you picture a typical rectangle, horizontal, all of a sudden, when we get above y equals 4, the formula for the length of that rectangle changes. Okay, and we have to these horizontal distances are in terms of y. So we have, if we think of this as y equals x squared, and then solve that for x, you get x equals plus or minus the square root of y. And so for each y sub I along in here, the x coordinate of this point is positive square root of y. And the x coordinate of this point is the negative square root of y. And this total distance is x coordinate at the right minus x coordinate at the left. And that's what this is right here. X coordinate at the right minus x coordinate at the left. And these rectangles, where we're dealing with the parabola from 0 to 4, well, they stop at 4. Once we get above y equals 4, we have to use a different formula. And the x coordinate of this point, if we solve this for y, we've got for x, y equals 6 minus x. 6 minus x gives us x equals 6 minus y. So the x coordinate of this point right here is 6 minus y. For each y going from 4 to 9, and the x coordinate of this point is the negative square root of y. comma y. And so that's what this is right here. X coordinate at the right minus X coordinate at the left. You can see that we get the same answer both ways. Obviously, integrating with respect to X is a lot simpler. Okay, there you go. Hope that helped. If you have any questions, post a comment.